what is the first derivative of that mysterious function s? And here it comes, the amazing part. The function s is so mysterious, it's hard to even say something or anything about it. But we're going to be able to compute what the derivative is without even knowing the formula for s. Well, the way we'll do it is by saying, by definition, that derivative is the limit as delta t goes to 0 of the ratio, the change of the function s of t plus delta t minus s of t, divided by the change of the function t, simply delta t. That's the definition. And now I'll do a little trick, rewriting that fraction in a little different way. And what I involve is this picture of how the cars are moving. So what I have there is, I have some time t, and at that time the first car is in the position f of t, right here. And that position corresponds to the time s of t for the second car, when the second car was exactly at the same time, at the same position, g of s of t. Okay? So that was a part of the definition of the function s of t. Now, what happens when the time delta t passes? T becomes t plus delta t, and the first car shows up at a different point, somewhere there. What about that point? Well, this is going to be exactly the point where the second car is when t is equal to t plus delta t. So at that time, the second car is exactly at the same point. So, what is it that I see there in the fraction? What is going to be s of t plus delta t minus s of t? What's the meaning of that difference? Well, that is the time spent by the second car as it moved from this point to that point. So this is delta s, the time spent by the second car. And what I want to relate it to is I want to relate it to the time spent by the first car as it moved from the same first point to the same ending point. So, two cars were traveling along the same segment of the road and spent different times. Now, if I relate that time spent to the length of the segment, let's call it delta L, the length of the segment of the road, and I multiply by delta L back so that the fraction is kept, then this fraction has the perfect meaning. The distance traveled by the first car divided by the time spent. That's the speed of the first car. The speed of the first car is the magnitude of the velocity. Now, what is that fraction? Well, that fraction is the reciprocal of the speed of the second car, which is equal to the magnitude of velocity. So the whole thing, the whole limit, is going to be the fraction f prime divided by g prime. It is simply the ratio of the speed. Well, it should be the speed, not the vector. Right? So that's the amazing thing. We found the formula for the derivative of s. An exact explicit formula in terms of f and g, although we had no idea what the formula for s is. That's what I like about this. Well, the highly non-trivial use of the concept of a function. I didn't use any formula for the function, just the idea of the existence of the function. And some definition of derivative helped me to differentiate.